example that we're going to show you with the moment is that where we get into a flood damaged area that gets some scanning for those guys. So another thing that we like to do, and we're one of the first people in the country that's actually doing this, is we're combining aerial photographic data with ground-based laser scanning data. And that's a really nice combination. What we find is that the drone aerial data gives you the fantastic colors, it gives you the real-world texture of what actually looked like on the ground when you were there. The laser, though, gives you fantastic geometry. We're talking about accuracy up to 2 millimeters from 300 meters away. So if I set a laser scanner down in this corner right here, we can scan out everything within line of sight for 300 meters, and it'll be accurate down to 2 millimeters. Now when we combine those two, but then the downfall is that the laser doesn't give you quite as good of a color as the photograph. Built out with all and it's also, now we're seeing much more economical versions built out with, say, a string of high cameras rather than DSLRs. As you can imagine, that really brings the cost down and the complexity of it down. It gives you a lot more control too. So, a couple of examples of our work. This is actually a landfill. There is a site near us called Sparrows Point, Maryland. This at one point was the largest employer in the state. You can see this landfill here. It's filled with construction debris and a lot of asbestos, and there's a big environmental remediation photos in such a way that allows us later to reconstruct these. So what we found is that we just kind of automatically found ourselves photographing, and when we were all said and done, we had enough data to create this entire model. Now we weren't really trying to do anything on the sides, we weren't really trying to do anything on the ground, so some of those great spots that are there it's a little short, but the actual area of the church itself was very well filled in. And this was only from a few hundred photos. I would say it's been about 250 to 300 photos. So this one right here is another example that we were talking about earlier, combining the drone data and the laser data. And I'll set the story up in this one first before I let it go. But this is an area called Ellicott City, just outside of Baltimore, Maryland. And recently, Ellicott City suffered from some really bad floods. They called it the 1,000-year flood. I know personally in the last 10 years we've had 2 of those 1,000-year floods, so maybe they can come up with a better name. But essentially, this was a torrential downpour. It dumped about 6 inches of rain in about a 30-minute time span, and it's at the bottom of the hill here. This site has been around since the late 1700s, early 1800s. They had the first few buildings in here, and essentially it was wiped out. Water was coming down and blowing cars down the street. They lost a total of about 75 cars alone. This entire area through here has been completely closed off now. What we did was we came in and we worked with a drone, laser crew on the ground, and we flew the drones in the air. Each one of these dots that you see here in the air is the location that we were positioned when we took the photograph. So this is kind of a nice zigzag pattern. What we did is we flew back and forth in this long path, and then once we got to the end of that, then we flew back and forth in a short path, and we broke it up into 2 different points. So this is what's known as a point cloud. This is the entire site, and now this is just the drone data, but it's in the process of being merged with the laser scan data. So everything that the laser missed, we were able to get, namely the tops of buildings, anything behind, a certain architectural feature, anything, all the trees and everything else up really high like that, we were able to pick up. And we can get the stuff on the ground too. We certainly get the colors. We get some of the geometry. It's pretty close. It's not as close as the laser gets though. So that's why combining the two, this is a really good example of this. I'm happy to say that the state and the county actually asked us specifically to come out and work for this after they had the floods there, and they've since donated this data. We donated our time, and they've donated this data to all the historical architectural firms in the area that are trying to take it back to its exact state that was in prior to the flood. So we're really happy about our work that we've done with this one. Again, this particular site, one of the advantages of using a drone to do this is the speed at which we collect this data. We flew both of these missions inside 20 minutes. The laser crew on the ground, it took them pretty much the whole day to walk this. They kind of had 2 lasers and they were leapfrogging these things back to back. the one over the other. And really, I can't stress how time efficient using a drone like this can really be. It's just a much faster way to be able to capture this. We've got another example. But once the data is collected, it doesn't change. And we can give them an exact time stamp that says this pile was X number of cubic yards at this exact minute in time. From there, they can then use their own internal inventory mechanisms to figure out how it's shown here. And the actual 3D print version, there was a little bit of cleanup that had to get done around back here. There was some debris, some open windows, and some debris hanging off there. But for the most part, what you see is what you printed. And I can actually show from above what that print looks like. So that's the print that we're talking about. And this is the building. So that was actually printed stainless clay here for a French exchange rates. They do a fantastic job with the color coding. So this one now is not only physically documented, but it's also digitally documented. If for some reason we lose the bid and they go ahead and demolish this building, we still have a foundation built on top of the foundation. So they know that this layer that we have here is one structure that was built on top of another structure, which is this one right here. So what they'll have us do is we will actually come out at various times throughout the process, and we will do these scans for them, and they almost become layers. So we will scan the first layer, then they'll remove it, we'll come back and scan the second layer, and then we can then animate between those and show what the building would have looked like. But one of the cool things I found in this one was there was a broken plate there. Now, I don't normally get to see any artifacts that they pull out of these sites. This one was still in the ground, still showing that fine china plate that was there. Who knows how old this thing is? It's definitely from the late 1700s. I do know that much. But what's the story behind that? How did that become